Question 3, determine the value of alpha, if any, in this differential equation, y double prime minus the coefficient at y prime is 2 alpha minus 1, plus the coefficient at y is alpha times alpha minus 1 is 0, for which all solutions tend to 0. That's the first part. And the second is for which all non-zero solutions become unbounded as t approaches infinity. Now, how do we approach this? So recall that a general solution of a second order differential homogeneous linear equation with constant coefficient is some constant c1 times e to the power r1 t plus some constant c2 times e to the power r2 t. So where r1 and r2 are roots of the characteristic equation. But the characteristic equation is a quadratic equation. And for the quadratic equation, we know Viet's formula. So according to Viet's formula, r1 times r2 is alpha times alpha minus 1. So the product of r1 and r2 is the same as the product of alpha and alpha minus 1. And the sum of r1 and r2 is the negative coefficient at y prime, so which is 2 alpha minus 1. And I guess it's very easy to just, notice and to guess that, well, it means that r1 is alpha and r2 is alpha minus 1, right? So because now the product is indeed alpha times alpha minus 1, and the sum is indeed 2 alpha minus 1. Okay, so first part. Determine the values of alpha for which all solutions tend to 0 as t approaches infinity. Well, for all solutions to tend to 0, if t approach negative infinity, both r1 should be negative and r2 should be negative, right? So alpha should be negative and alpha minus 1 should be negative. But of course, if alpha is negative, then alpha minus 1 is even less than alpha, so it is also negative. So the answer to the first question is alpha should be negative. So also determine the values of alpha, if any, for which, so second question, for which all non-zero solutions become unbounded. So all non-zero solutions become unbounded as t goes to infinity. So on the contrary, so both exponents r1 and r2 should be positive, right? Because, if just one of them is negative and the other one is positive, then it is possible that C1 or C2 is 0, so the other C is not 0, and then solutions still approach 0. Okay, so which means that both of them have to be positive. But if both of them have to be positive, it means that alpha should be positive and alpha minus 1 should be positive. But if alpha minus 1 is positive, it means that alpha is bigger than 1. And of course, if alpha is bigger than 1, then in particular, alpha is bigger than 0. So the answer here is alpha is bigger than 1.